Okay, here's something we'll need. If the limit as n goes to infinity of the absolute value of an equals 0, then you can say without a doubt that the limit as n goes to infinity of just an without the absolute values equals 0. And I'm going to do a proof in here. We're going to do lots of proofs in this chapter. So here's your first one. Would you buy this inequality? Would you buy that a sub n is in between the opposite of the absolute value of a sub n and the absolute value of a sub n for any n? For any particular n. Doesn't that have to be true? Well, what do we know about the absolute value of a sub n according to the hypothesis here, the part before the comma? We know that the absolute value of a sub n converges to 0. We can assume that. That's part of the theorem, right? That's the first part. That's the assumption part of the theorem. And we can definitely, for any number, in other words, so if you have a number like 5, isn't 5 in between negative 5 and positive 5? Isn't that a true statement? It's kind of lame, but isn't it true? Yeah. That's the sort of thing we're saying here. Well, what theorem can I use then to show that a sub n also converges to 0? Note that the limit as n goes to infinity of the opposite of the absolute value of a sub n. Well, if the absolute value of a sub n converges to 0, won't the opposite of those values converge to 0? Yeah. And, of course, we already know that the limit of the absolute value of a sub n equals 0. So what can we conclude? By squeeze theorem, since a sub n without the absolute values is in between the opposite of the absolute value of a sub n and the absolute value of a sub n, and those both converge to 0, we can conclude that a sub n converges to 0 by squeeze theorem. So the limit as n goes to infinity of just a sub n converges to 0 by squeeze theorem. I suppose this should be capitalized, right?